Elevators. Normally, your normal force and weight, Fg, cancel out because if one was greater than the other, you'd end up accelerating up or down. So the Fn is equal to Fg, because if Fn was greater, you'd accelerate up. If Fg was greater, you'd accelerate down. Now, in an elevator, you can accelerate up and down, so Fn might not equal Fg. The Earth pulls down on you the same no matter what. Fg equals mg. When you feel lighter or heavier on or your scale reads a different number on an elevator, that's because the normal force is changing. The force of gravity will stay the same, but the normal force changes. If you're accelerating up, that means you're moving up and speeding up, or moving down and slowing down. The normal force is greater than the force of gravity. You feel heavier, and the net force points upwards. If you're moving up or down with constant velocity, it can be up or down. Notice constant velocity. That means the Fn and Fg have to be equally to each other, and the Fnet's equal to 0. You're in equilibrium. Finally, accelerating down. If you're moving up and slowing down, or moving down and speeding up, the Fn is less than Fg. You end up feeling lighter, and the Fnet points downwards. Alright, a sample problem. An elevator accelerates upwards at 2.2 meters per second squared. The acceleration of gravity is 9.8 meters per second squared. What's the upward force exerted by the floor of the elevator on a 22 kilogram passenger? Okay, it's asking for the normal force. It's accelerating upwards, so the normal force is greater than the force of gravity. So how much greater? First we have to find the net force. The net force is equal to mass times acceleration, is equal to 48.4 newtons. So I know the normal force is 48.4 newtons greater than the force of gravity. Force of gravity we can calculate, Fg equals mg, is 215.6 newtons. So the normal force is 48.4 newtons greater than that, is a total of 264 newtons. And that's your answer. Now let's try the same problem, but with the elevator accelerating downwards. This time the elevator is accelerating down, asking for normal force again, but the normal force is less than the force of gravity. How much less? Same amount as last time, 48.4 newtons, but this time it's less than Fg, so we subtract the 48.4 newtons from the force of gravity and get 215.6 newtons minus 48.4 newtons equals 167.2 newtons.